All right, we want to welcome you all here this afternoon to MIU, to our Tech Talk. It's Saturday morning, and we're very grateful and glad to have with us Dr. Leon Gatys. As you see, he's on screen here. He's a machine learning researcher, and his focus is on understanding how data-driven technology can improve our experience, our human experience. He received his BSc in theoretical physics from University College in London in 2013 and finished his Ph.D. in machine learning and computational neuroscience at the University of Tübingen in 2017. And during that PhD, he worked with Professor Matthias Bethge, sorry for my pronunciation, Leon. And with him, they invented the popular neural style transfer algorithm. This is one of the first works that demonstrated the potential of generative AI, ChatGPT as we are using it today. And after that, he joined Apple, and he was a research scientist with Apple from 2018 till 2022, where he worked as a founding member of their health AI team. And now he's working on his own company. He co-founded a company which he'll probably tell us about, called Measure Labs. And what he's interested in is developing some health sensing, scalable operations for smartphones. Now you can tell us what that is, Leon, correct? Thank you so much for joining us. I'm sorry if I bungled your introduction, but you can let us know who you are as well. Thank you.
Thank you so much, Cynthia. That was beautiful.
Welcome.
For the great introduction. Let me start sharing my screen. All right, well, today I won't be talking about our company because that's slightly tangential to the topic I'll be talking about today, which is generative AI, looking at the development and the possible future impact of generative AI, which of course is a very fast-moving field and a very vast topic. So I can only offer a limited perspective here, but I hope it's going to be a useful one. By the way, the image on the title slide here, I created that with the DALL-E algorithm with the prompt, "A robot gaining consciousness and experiencing pure bliss." So I thought this audience might appreciate that. So why do we care about generative AI? I think we care for two reasons. The first is we really see unprecedented user adoption. So ChatGPT, which is the prominent use case that was recently released, only took 2 months to achieve 100 million monthly active users. And that's way quicker than any other viral social networks before it. So really, there are a lot of people who want to interact with these kinds of technologies. And at the same time, we also see unprecedented developer adoption. So on the right, you see the number of GitHub stars for the Stable Diffusion repository, which is a toolkit to generate images and build image generation models. And you can see this very sharp light blue line in the beginning. You can really see it skyrocketing compared to other popular repositories. And that means there are a lot of people out there, a lot of developers who want to build technologies and experiences and applications around generative AI. So it's really a big topic for many people. Let's have a look what we call generative AI. And let's explore that a little by considering a machine learning model that gets its input this image and outputs something from that image. So if it were to output just what is seen on the image, so for example, just the word turtle or even the sentence, "two turtles sitting at a table," we would probably not call that generative AI. We would call that image classification or image captioning. And that kind of technology has been around for pretty much 10 years and longer. Even though the model is generating an output, it is generating a sentence. But what if the model outputs a paragraph like this, like saying, "Seated across from each other at a weathered wooden table, an elderly turtle couple found themselves enveloped in a poignant silence," and so on and so forth. Suddenly we start to think, wow, this is something different. This is something new. This is what we call generative AI. And similar, if we were to output an image and transform this image, so have the turtles here play cards instead of having drinks, we would call that generative AI. And I think the deciding factor really is the complexity and dimensionality of the output space. So there's some fuzzy level between just outputting a sentence and outputting a whole paragraph. There's some change in complexity that is a qualitative change from where on we call the technology generative AI. And so what I want to do first today, I want to start by looking over recent history and development of generative AI and introduce a few core technologies. And I want to start with image generation. I believe the first results in terms of generative AI in the recent history of deep learning were really the Google Deep Dream algorithm from 2015. In that algorithm, we actually don't train a model to generate images, but we use a model that was trained to classify images. And then we generate, with that model, we create images that maximize the activity of certain neurons in the artificial neural network. And you can think of that like we're generating images that look psychedelic to the network. And excitingly, people found that these images also generate very cool perceptual effects for humans. And there was a lot of excitement around these images. And you can see a beautiful example here on the screen. Around the same time in my PhD thesis, we pretty much experimented with the same technology. And we designed handcrafted representations of image content and style, which then enabled us to take a photograph, like here, this picture of Tübingen, which is the town where I did my PhD, and make it look like it was painted by Van Gogh by transferring the style from the Van Gogh Starry Night painting. And again, lots of people were really excited about these images and about generating them. And both of these results were early evidence that deep neural networks learn something that is very relevant to human perception and enables new ways of creating images and perceptual experiences. From there on, in the following years, the research community really focused on actually training networks to generate images. And it took some time, but from around 2016 to 2018, people were starting to get really good at generating images. And this started to have a very interesting societal impact. So here you can see an image that is called Portrait of Edmund Bellamy, which was sold for almost $500,000 in October 2018. And I think it's still the most expensive AI-generated artwork up to today. And really changed a lot of how the general public was perceiving AI. But this technology also gave rise to the ability to create high-quality fake media. Let's have a look at the following video.
This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of dystopia. Thank you. Stay woke.
So I apologize for the strong language in the image, but this video was generated by BuzzFeed in 2018, and this is an example of what we call deep fakes. And the important thing is that the former US President Obama was not involved in making this video at all. And so deep fakes are images or videos or just audio of a person doing or saying something that is completely invented, but looks very real. And of course, this again has huge societal implications. It can be an incredible tool for the content creation industry, but it can also be used to spread political misinformation. Or it can be used to create non-consensual sexualized content, which really has become a significant problem in recent years. And all this together kind of demonstrates the impact of these technologies on society, even as early as 2018, so 5 years ago. So where are we now with image generation? This is an example of the DALL-E 2 algorithm, the same algorithm I used to create the image on the title slide. And it creates image generation with text input and really enabled image generation in unprecedented quality. So here, all the human had to do was input the sentence that's shown underneath the image. So on the top left, it says a vibrant portrait painting of Salvador Dali with a robotic half face. And the model would generate the whole image from scratch. And I think everyone, including myself, was really, really impressed with these images when they first came out, and still are. And so this kind of demonstrates why people are very excited to use these technologies in the image generation space. Now, image generation is not the only thing that we know is very exciting right now. So let's look at language. The big super important technology that I want to introduce are, of course, large language models, or LLMs in short. The most prominent example is probably the generative pre-trained transformers, or in short, GPT, and many people here will have heard about it. This model was released by OpenAI in the first version in 2018, and the most recent version, GPT-4, was just released earlier this year. Large language models are trained to predict the next word in a text sequence. So here you show the model the words, "the chicken walked," and ask what the next word is. The model will guess a word, and you give it the feedback that the correct word had been across, and then update the model. And if you repeat that over a large amount of training data, over time, the model learns the structure in natural language, and it becomes very good at guessing what the next word in the sequence is. And importantly, you can show that to solve this task, the model starts to learn and represent a lot of general knowledge about the world that you can later on extract and make the model useful. For example, if you present the sentence, "the capital of France is," the model will, with very high probability, want to continue the sentence with the word Paris. And suddenly you have a technology that allows you question answering from natural language. GPT-4 achieves very impressive performance on tasks originally designed for humans, such as standard college entrance exams in the US, the SAT, and some people of you might have heard about this. By now, all the major tech companies like Google, Microsoft, or Facebook build their own large language models, and it's become a core technology. And it's not just an academic exercise. These technologies have actually been deployed already and are impacting a lot of people's lives. A prime example is code completion in software engineering. So here you see an example for the GitHub Copilot product that was released a year ago. And what you see here is that the human only has to write the initial name of a class definition, and the Copilot, the AI, is suggesting a very complex continuation that are often very valuable and correct. So as I mentioned, this was deployed around 1 year ago. GitHub says there are over 1 million users and more than 20,000 organizations that have adopted this technology by now. And I recommend to anyone who codes to give it a try. It's not perfect, and you still have to do the thinking and check for mistakes and so on. But it really profoundly improves productivity, especially around repetitive tasks in coding. And I'm absolutely convinced this is the future of software engineering. And of course, the most prominent recent application of large language models is chat interfaces, such as ChatGPT. ChatGPT is adapted from the base language model to support dialogue interactions. It has very impressive conversational abilities. So for example, when you ask it, "Are you sentient?" it will give you an answer like, "As a machine learning model, I'm not capable of sentience or consciousness. I'm a large language model trained by OpenAI to generate text based on the input I receive." And so on and so forth. And then it says, "I apologize if this is not the answer you were looking for. Is there something else I can help you with?" By the way, of course, this would be exactly the answer that a sentient AI would give us if it doesn't want us to believe that it's sentient. But you can see how these models are very impressive. But at the same time, we've also seen these models hallucinate information or showing other undesirable behavior. And we are only at the beginning to understand this technology and what is possible with it. But nevertheless, where we are right now, in just a year or half a year after these technologies were publicly released, is that we have a vast amount of applications and products in the generative AI space. We have chat interfaces, we have writing tools, we have code generation, as you've seen. We have lots of image and video generation and editing tools. We have applications around design workflows. We have applications to generate speech and music, to clone somebody's voice, for example. We have applications around 3D assets for virtual reality or computer games. And we even see exciting results in science where people are using generative AI, for example, to predict chemical reactions from compounds that haven't reacted before. And all in all, we really see generative AI adopted in all digital workflows across the board. And so, of course, everybody now is really interested in where do we go from here, and what does the future of this technology look like? And like everyone else, of course, I can only speculate. But what I want to do in the following is I want to try to derive some insights in a systematic manner. And what I want to do is I want to share some observations about the generative AI space currently and give some examples, and then try to derive what that might imply for the future. Now, the first main observation that we already talked about is that we see applications across all digital workflows. And let me just give you an example for content creation, where somebody is using the new Adobe Generative Fill feature. And so, again, very impressive. And I mean, of course, this example is cherry-picked, but we see plenty of similar impressive examples in different domains. And so, you know, we have similar examples in chat-based search engines like ChatGPT. Anyone who has tried writing tools based on generative AI knows that it's very impressive. And as we've just seen, content creation is a huge opportunity for these technologies. And so in terms of future impact, I believe it's fair to say that generative AI will be a staple good for all digital workflows. Anytime anyone is doing something on a computer, it is very likely they will interact with generative AI in the future. I also think that the loop between content consumption and content creation will become tighter. Generating high quality content will become cheaper and cheaper with these tools. And we've already have very advanced recommender systems, for example, movie recommendation on Netflix. And in the future, I think they will more directly interact with the content creation process, so that we not only recommend movies that are out there, but we start generating movies that directly take the information from the recommender system to understand what consumers want. At the same time, though, I think humans will stay in the loop and accountable. We've seen that generative AI is very good in workflows where errors are not costly, and there are humans in the loop for error correction and selecting final outputs. And the hope is, of course, that in this hybrid workflows, humans will be able to focus on higher level abstractions of the tasks. So, for example, for software engineering, that humans rather do the code design than all the low-level implementation details. And I think a very important area of work there is that we need better tooling to enable these hybrid workflows. So, for example, we need better tools for humans to check that code that AI generated is actually performing the function that it should perform, so that humans can focus on the more high-level abstractions of the workflow. Now, the next observation I want to share is that increasing the scale of these models makes all the difference. And basically all the recent breakthroughs were based on an increase in scale. So for example, the main innovation from the first GPT in 2018, which was a nice research paper, but maybe not much more, to GPT-4, which profoundly impacts our society, is just a dramatic increase in the scale of the training data, the scale of the model size, and the amount of computation needed to train the model. And importantly, we see an unexpected emergence of abilities in this model with increasing scale. That means a quantitative change in the system parameters, so just making it bigger, leads to a qualitative change in the system's behavior. And here on the right, we see a graph that demonstrates that for the ability of adding 3 digits and how it arises in GPT-3. Until you reach a certain model size on the x-axis, you see that the performance of the model to do this task is really 0. There's no indication that this model could do this task. But at some point, if you use the same model and just make it bigger, you can see that task performance skyrockets. So really, we don't really know what other abilities might be possible with these models when we increase their scale even further. And then finally, for image generation, we've also seen that the recent breakthroughs in quality were only possible with costly new models that are called diffusion models. And again, an increase in scale made the difference. And so I think when we project these observations into the future, I think this profound impact of scale will further accelerate the development of customized hardware stacks for generative AI. OpenAI reported that a large part of the effort that went into GPT-4 was spent on co-developing a custom compute cluster with Microsoft Azure to enable the required scale. I also think there's a great opportunity for edge devices that are optimized to run neural networks, for example, laptops and smartphones. Since the ongoing costs of generating these images and text are pretty substantial, it's a real game changer for developers if they can offload these compute costs to the edge devices and don't have to run a server in the background where that generates this data. And so both Apple and Samsung, they really invest heavily in building better neural network hardware into their mobile phones and into their laptops and other devices. And I think that will only further increase. Now, the last interesting question is whether we will just see an increase in data quantity or whether there will be a similar focus on data quality. So the question here is, will GPT-5 just train on 10 times of the data, or will it stay maybe more on a similar level and rather invest in trying to improve the quality of the data that is trained on? And the answer to that might be that it's doing both. But yeah, increasing scale is a very, very central and fundamental factor in generative AI. Now, the next observation that is very important, I think, is that controlling generative AI behavior is very difficult. And there is a large effort that goes into making large language models useful. And the cartoon on the right that you see is, and this went pretty viral in the community, and that illustrates how we get from a pure language model like GPT to a useful chat interface like ChatGPT. First, for the pure language model, you create that with unsupervised pre-training. So this is just training the model to predict the next word on pretty much all the data on the internet and more. And this is illustrated here in terms of this monstrous creature that contains all kind of human thought and behavior. I think in reality, it's not that much of a monster, but really just a collection of all different kinds of human perspectives and behavior melted together. but still, I think it's very big and very messy, and you don't really know what's in there. And so from that basis, now you want to obtain a model that's particularly good at following instructions and giving helpful and correct answers. And that is usually done by fine-tuning the model on a smaller curated data set, which contains examples of responding to questions and following instructions. And this step is here illustrated by the human face mask in the picture. As you're trying to focus the model to display just a specific aspect of the human abilities that are in the vast pre-training data that it has seen before. And finally, you adjust the model based on direct human feedback. And this is called reinforcement learning from human feedback, or RLHF in short. And that is illustrated here by the little smiley face, because in that stage, you often try to ensure that the model is displaying agreeable behavior and that it doesn't output anything that would be harmful or hurtful to the people interacting with it. And the message here is really, there's a lot in this model that it picks up during the initial pre-training phase, and that we don't want the model to output during deployment, because there's a lot of stuff on the internet that you don't want to expose and reinforce through a chatbot. And there's a substantial effort that goes into having the model only expose the good and helpful parts of that initial data to the user. But nevertheless, in practice, we see that models are still hallucinating false facts, or they can be kind of tricked into exposing unsafe or hurtful information. So, and this is basically going beyond the smiley face and the human mask and exposing some of the stuff that lies hidden beneath, that is somewhere present in the model. And so in general, it is just very hard to reliably control all the different kinds of outputs a chatbot might produce in all different kinds of scenarios. Apart from that, I think, as a side note, there's also another separate but very interesting aspect on controlling the outputs of generative AI. And that is that it's very easy to generate a vague idea, but very hard to generate a clear idea. And what I mean by that is, if you just want something like, Salvador Dali with a half robotic face, it's something that you probably don't have a clear idea of what that should look like. And the model can produce these very interesting and fascinating outputs. But if you have a very clear idea of an image that you want to generate and how that should look like, it's actually quite hard to get any of these generative models to output something that looks just like what you had in mind. And so, what does all of that imply for the future? My personal bet is that people will invest in better tools for large-scale data curation, basically trying to make the scary monster underneath look less scary by controlling better what data the model sees in the first place. I also think there's a lot of potential for improving the user experience to make the outputs of the models more structured and more reliable. So for example, you could require the model every time when it claims a fact to also provide you with a source reference and a clear indication where it acquired this knowledge from. And this is something that a lot of people are already working on, and I think it will only become more, and we will see an improvement in these interactions. I also think that personalization is key. And that basically means, how can every individual kind of make sure that the human, or every user, make sure that the human mask and the smiley face that you kind of plug onto, the big base model, how can we make sure that that is actually, or contains the abilities and the aspects of the human qualities in the base model that I, as a specific user, want? And so I can imagine that it will become very standard for users to provide additional examples or content to adapt models to their personal use cases. And I think things like the new system context prompt in GPT-4 is a good example of that. And finally, I believe that our overall expectations of machine behavior will shift. Machines used to have very constrained input interfaces, but were very reliable in their outputs. And now we're kind of seeing that shifting, in that machines start to accept are much more flexible in accepting inputs. We can just talk to the machines, right? We can just talk to a computer. But at the same time, they also become less reliable in the outputs they produce. And I think those two are sort of related. All right, and the final observation that I want to share with you is that human attention is the most valuable resource. And we see that over and over again in the generative AI space. Let's have a look at the cartoon on the right. So on the left side, the person tells their colleague, hey, AI turns a single bullet point into a long email I can pretend that I wrote. And on the right side, another colleague tells their coworker, hey, AI makes a single bullet point out of this long email I can pretend I read. And so really, I think we can categorize applications in the generative AI space into those that help you to capture attention. So for example, content creation, entertainment, or writing a long email from a single bullet point. And those who try to help you save attention, like more efficient search engines or content summaries that turn a long email into a single bullet point, for example. And of course, for productivity applications, it's often a combination of both. It's often capture as much attention while spending as little attention of your own. As a side note, one thing that's very interesting is if you look at the kind of data that captures most attention, it's often human data across all modalities. So for example, generating images of faces or cloning somebody's voice or trying to simulate the personality of a famous person, for example. And so I think the implications of all of these observations for the future is, first of all, I think in the future, we will assume that any digital content that we consume is at least co-generated by AI. And that will lead to very interesting dynamics, because think about how motivated are you to read a long email if you know that it has been generated by AI. And related to that, I think there are these interesting adversarial dynamics between AI tools. So between those who try to help you save attention and those that try to capture your attention. And actually, I believe that maybe, but just maybe, this is an opportunity for us as humans to focus more on trusted human-to-human interactions. Because if you start to see that all the content that you see online on social media and so on and so forth, if you don't know whether it's real or whether it's generated, you might at some point, want to spend more time offline and actually in a scenario where you know that you're interacting with a real human being. Okay, so finally, as a final part of this talk, I want to also highlight some risks and opportunities arising from generative AI. Initially, I had only risks here, but I realized that some of them are also opportunities, and it's very nice to highlight the positive potential as well. So let's start with the quality of the tools that we have available. First of all, I think the legal status of the training data from the web is pretty unclear right now, as well as the willingness to provide that data for free. So just very recently, the New York Times started blocking the web crawler from OpenAI to prevent the use of New York Times data as training data for GPT. And this could mean that high-quality, large-scale training data might not be as easily available in the future, possibly leading to a degradation in model performance. But I think it's also an opportunity, maybe for a fairer compensation of high-quality content creators if their data is used to build these models. Second, I think there will be increasing pressure to monetize generative AI tools like ChatGPT or Microsoft's Bing or Google's Bard. Right now, these tools are very heavily subsidized, and trying to monetize them can degrade the UX. And that's true just the same as in traditional search engines, where you have these additional advertisements that are not great for user experience, but that are shown to you to make money. And similarly, you can imagine the amazing recommender system Amazon could build if they weren't trying to make a profit from it. But actually, I think this can also be an opportunity, because traditionally the business model is that the user doesn't pay, but they get presented with ads in traditional Google search, for example. I think if business models where the end user directly pays for the service, if those prove successful, we actually might end up with search engines and recommender systems that really try to maximize the value for the user. And that could be very exciting technology, I think. And then third, I think there's a very interesting challenge with feedback loops in the training data, as increasing amount of text and images on the web will be generated by AI in the first place. It's very hard to fully understand the consequences of this, but it's certainly something to watch out for. And there are many people already working on things like digital watermarks to try to make AI-generated content clearly discriminable from human-generated content. And that's a very important research area as well. The next domain of risk that I want to talk about is social risks. And a very direct risk of generative AI is to amplify existing social issues that express themselves in the training data. Let's watch a short video that illustrates how image generation models can reinforce societal biases. So really what we see in this short little video is how existing issues or existing biases in society are reinforced by the AI because it's just reproducing the training data. And we see very similar behavior for language models and chatbots. And there's another more subtle risk that these models are often trained to cater to human preferences, and they can actually learn to tell you what you want to hear depending on its model of you. And so it might further facilitate the creation of filter bubbles. Of course, there is a big opportunity with this, which is if we are adjusting AI models to reflect a more balanced view of society, I think it can really act as a balancing force that over time supports and alleviates imbalances and societal issues. And there's a lot of important work in the research community on that right now. Now, a second big risk that many of you probably heard about is the spreading of false information. And that can be either through humans using AI to fabricate data, like in the deep fakes we talked about, but also AI chatbots often very confidently mix facts with hallucinated information. And it can be quite challenging to verify output from generative AI. But again, I also, and this is a big challenge, but I also think it's an opportunity because we have to start becoming more intentional and explicit about how we define truth and establish process to verify them. And finally, I think a very real long-term risk can be what I would call silent quitting in human social life. What I mean by that is that humans might increasingly satisfy their social needs through virtual AI agents and limit their social interactions with other humans to the bare minimum. And the question is, if you can generate your perfect dream, do you want to wake up? And I think generating the perfect dream, at least in terms of images and characters or virtual agents and sound, I don't think we are too far off. I can imagine that technology being there in maybe 5 to 10 years. On the other hand, I also think that interacting with AI agents that are structured in the right way can be a tool for self-development and self-understanding. I think there's potential for building tools that help you structure your thoughts, and I think there can be great therapeutic applications. And I believe the question really is, can we build AI agents that support someone's evolution rather than exploiting their current limitations and trying to keep them stuck on a certain level of personal development? Now, the final piece of risk and opportunities I want to talk about is existential. And I do think it's an important topic to at least talk about, because we should acknowledge that we have a very powerful new technology here that we don't fully control and that already has profound impact on human society. And to be honest, the market dynamics do incentivize risk-taking and deploying these technologies in a risky way rather than a careful and measured approach. The best example, I think, is the recent release of the Bing and Bard chatbots from Microsoft and Google. So if we look at the headlines, we see something like Bing versus Google, the new AI-driven search wars are on. And so in this environment, in this sentiment, executives and companies are really incentivized to ship something prematurely. And when Microsoft Bing was released, it actually had very heavy flaws. The chatbot regularly went off the rails, displaying very undesired behavior patterns, and in some cases even threatening users. And similarly, I think the Bard chatbot from Google maybe a little bit, was maybe a little bit more mature, but I think it was still released more quickly than many people at Google felt comfortable with. A prominent example is that AI research legend Jeff Hinton actually resigned from Google, and part of the reasons why he resigned was that he wanted to be free to speak more openly about the dangers of AI technology, and he felt there was a conflict of interest of doing that while still being at Google. But I think in this market environment, it's very important to keep in mind that AI agents can be very easily misaligned with human goals. These models, they learn from data, but the data can rarely capture the full extent of the desired functionality they are supposed to learn. And so this can lead, for example, to AI models learning to solve the task it's supposed to learn, but in very undesired ways, kind of exploiting certain, taking certain shortcuts that humans didn't think about in the first place. Or the AI model can actually learn to optimize a goal that's consistent with the training data, but not exactly the goal that it was intended to optimize for by humans. And so this is really a very important, again, a research direction, and it's very important for us, I think, to take a careful approach releasing these models. There is a big opportunity here too, though, as this will really push us to be more intentional about and more transparent about what are the goals and values that I want an AI model to be aligned with, and to explore whether these goals and values are really captured by the training data. And so now finally, the last big point that I think is maybe even the most important point of the whole presentation is that I think we should never forget that AI is nothing separate from us. It is a representation of collective human intelligence and consciousness because it learns the patterns in the data that we produce in the first place. And that can be a risk because history has plenty of examples for how human intelligence can create devastating results and suffering, but it's also very empowering. I believe the most sustainable way to direct AI systems in a life-supporting direction is to direct ourselves into that direction. You always have to educate yourself first before you can educate others. And I think that's still true if the entity you're educating is a machine. And so one used to say, be the change that you want to see in the world. And I think these days, with respect to generative AI, we can say even more concretely, be the training data that you want AI systems to learn from. And with that, I thank you very much for your attention. I hope that we have a bright future of human-machine collaboration ahead of us to enjoy, and I'm happy to take any questions. Thank you very much.
So I wanted to ask, could you please provide some references of books for the ones who haven't started AI for the complete beginners to start something in that field?
Yeah, absolutely. I mean, it's a very fast-moving field, so books are outdated quickly. I think one book that I think gives a very good foundation is I think it's called The Deep Learning Book by Ian Goodfellow. I think it was released, a few years ago. It has a very good foundation, like a brief and concise, but good foundation also into the mathematical prerequisites that are important for current AI models, and has a very clearly outlines certain different technologies. I think if you want to learn more about generative AI in specific, and again, it's such a fast-moving field, I think the best shot you have is really Googling recent resources. Look at prominent researchers from the field. They some of them may have blog posts or explaining certain things. Yeah, it's really a bit of a moving target, but I think trying to find content, sometimes also slides from university degrees are online. Yeah, I think that's sort of what I can recommend. But I think what's very important is to look at make sure that you're comfortable with the mathematical foundations. That is things like linear algebra, things like probability and statistics. If you feel comfortable with those, then it's much easier to put these modern AI models into context and kind of also start working on them yourselves.
Can you hear me?
Yes.
So I would like to first thank you for your presentation. I really loved it. It was really amazing. So my question is about what does it take exactly to find a job as an AI engineer in this market, knowing that it's very tough to find a job. So I was just trying to know what is it exactly that we need to do, to find a job in AI exactly.
And it's so fast moving too.
Yeah.
Again, great question. I think getting a graduate degree that at least to some extent focuses on these technologies is very useful. I think getting some hands-on experience by looking at public GitHub repositories and starting to play around with models and following through some tutorials, just that you're very comfortable talking about different concepts in machine learning and different concepts of implementing these models and of evaluating these models. Just that when you're in an interview setting, that there's a good two-way conversation. I mean, it's hard to say what exactly you need to do. I think it also depends. I think big companies have very different screening procedures or hiring procedures than startups, for example. I think in general it's good to cast a wide net, but yeah, ideally sending more than maybe just a CV, but also why you're interested to work at that place and give some reasons. But I agree. It's not an easy problem for both sides, right? Companies get a lot of applications, applicants send a lot of applications, and I think we're still not there where kind of this matching system is perfect. But I think the most important thing is really make sure that you're curious about the space, you're learning something every day. Make sure you're able to explain to yourself and others what you're learning. Make sure that take care of yourself, being very comfortable in that space. And I think from that position of strength, the right opportunities will come along. But I think it's really important, this try to keep like buzzwords and like buzzwords to the minimum, and just make sure that everything you talk about you really understand, and practice with your friends, try to explain stuff to each other, and make sure that there's a you start to get a very clear picture of the space that you can explain to yourself and others. But yeah, that's really what I would be looking for in interviews and hiring. And I think many other companies too.
That's a great.
Thank you so much.
That's a great question, and a big
And a
concern.
hard one. I'm sorry if I couldn't be more helpful.
Yeah, that was helpful.
Yes.
Other questions here from this side of the room? Anybody?
Okay, first, thank you so much for the brief, excellent presentation and very informative. My question is if you can share us your experience at Apple in regarding to AI, and what would you advise for fresh graduates to get a job in Apple, especially do we have to know AI? Thank you.
Question. Okay, everybody wants to go work at Apple. Leah. Thanks for help.
So yeah, great question. I think there are lots of jobs at Apple where you don't necessarily need to know AI, right? Absolutely. It's a massive company across hardware and software. And I would even claim, and that's true, I think, for most of the big tech company, that, the majority of the jobs don't require a deep knowledge in AI yet. It's good to become kind of comfortable, knowing about the space a little bit, and kind of having at least a picture to know what you don't know, right? And that's important. But yeah, how to get a job at Apple? Again, it's a difficult question, and the answer will be very different for different backgrounds and different situations. I think what is always really, really helpful, and this is actually true for the previous question as well. I think the easiest way into jobs at big tech companies is through internships. And I know the internship programs are also very competitive, but certainly everybody feels, naturally feels much happier, much more comfortable hiring someone if they have seen them work alongside them in the past. And even if it's just, even if you don't end up working in the team that you interned with, but that team can give a recommendation to some other part of the company. So I would really advise looking into internship opportunities at big tech companies if that is where you want your career to go.
My question is, how can we experiment with large language models? Do we need like a customized hardware or specialized hardware, or we can use like our own machines, open source tools?
Yeah, great question, and yeah, especially in the context of what I said in the talk. So interestingly, for these large language models, typically, or there are existing smaller versions that you can run on your laptop and even on the phone. So for example, for large language models, of course, we can't run the big GPT model on our laptop. But for example, Facebook has released what is called the Llama model. It stands for something with large language modeling. I'm not quite sure, but they released the Llama model, and they released smaller versions of it. They released multiple versions, and also a chat version of it, and I think also a code generation version of it. And I think all of that is publicly available, at least for non-commercial purposes. And you can look on GitHub, search for Meta, not Facebook, it's Meta now. Search for Meta Llama with the double L, I think. and you will be able to find a bunch of repositories that that would show you how you can try out these models and run them on your own machine. And I think for some of them you can also you can fine-tune them, and there are instructions of that online. So, I would advise, if you're interested in this, just Google their tutorials online, how you can fine-tune your own language model. And even these smaller models that you can run on your own machines, they can be very, very powerful. And you can, I think a really cool side project, if you have the time, would be to try to use a model like that and try to fine-tune it on some data of a certain public figure, to try to make a chatbot that's representative of a certain public figure, for example. That can be a fun side project where you would certainly learn a lot. And it's not a trivial exercise, but I think there are tutorials out there that try to do something like that.
Very interesting. And next question. That's so fun.
Sir, can you hear me?
Yes.
Okay, awesome. So mine is a little bit of a reflection as well, because first of all, thank you very much for the awesome presentation.
It's really great.
So you highlighting the risk and opportunities was really eye-opening. And what I understood from the presentation is that this technology has a lot of risks. So even though in the short term it can help us write code, generate images and everything, I feel like in the long term it can really impact our creativity, because I've noticed on myself and also in other colleagues that instead of us spending the time to research something or to be creative on some crucial fronts, I feel like we're resorting to using this kind of technology to just use it as a shortcut to generate stuff that we want to. And then also the very interesting point about how you mentioned, in 5 to 10 years, it can help us create this dream world of ourselves, where we're hooked to some VR, and we basically may not have the incentive to actually live in the real world. So my question is, if we're faced with this kinds of existential crisis, do you think the AI community has the courage to maybe pull the plug and disconnect this kind of technology? And another thing that I would like to mention is that, you mentioning being released without it mature enough, and also people at Google being in the company because Bard was prematurely released. I feel like there's a lot of motivation out of fear to release this kind of technology. So, at the end of the day, if it came down to it, do you think the community has the courage to, shut down this kind of technology? What do you think? Feels like an unstable equilibrium if you think about it in game theory, but happy to hear your thoughts.
Yeah, long question. I'm not sure if I caught everything, but maybe to answer the point about, would the AI community have the courage to pull the plug? I don't think it's about the AI community. I think it's about all of us, right? If it depends on what is the demand of the human society, right? And ultimately, I think living in virtual worlds is not fully satisfying if you have the awareness that can really appreciate and acknowledge the fullness of the real world, right? And so for example, there's a lot of things that I don't think will be solved in 5 to 10 years. So everything that we don't have good digital representations for. So for example, in terms of our senses, the sense of touch, the sense of smell, the sense of taste, it's actually a funny thing. 10 years ago, who would have thought that we have AI that can write poetry, but we don't have an AI cook yet, right? So that poetry is easier to replace, so to speak. But so what I want to say is, I think it's really about helping people appreciate the fullness of the analog world. And on that basis, I think we as a society have the stable foundation based on which we can make use of these tools and apply them when they're helpful, but at the same time not get lost in them, right? And and it's, it's already, to some extent, this is already happening, that some people spend all their lives just in front of a screen and kind of, just getting addicted to this high information output, and just have their intellect kind of constantly engaging with it, and sort of forgetting all the rest of the world. And I think it's really about creating environments and supporting people to appreciate the richness of the world that's out there. Because if you experience, and I think meditation is a very amazing tool for that, for example, right? Because this appreciation of the richness of the world, it comes from a level of silence and a level of relaxation. When you had a great night's sleep, and when you're really relaxed and you go out in nature, like the joy it can give you, and just the how it gives you input on all sensory levels, and that fullness, that's something that I don't think we can recreate in virtual settings anytime soon. And to appreciate that difference, and basically to give people the foundation based on which they don't get lost in the virtual worlds, I think it's very important for us to strengthen that ability to appreciate the real world, and create environments in which people, also create environments that don't have people being really stressed all the time, right?
Yeah.
And so then it's really, it's the AI community, or these companies, we are not separate from them, right? They create what we consume in a way, right? Or we as humanity, we create what we consume. So, it's all of us being responsible. But I think we have a great opportunity here.
Other questions, anybody? Yes, one more? No? Good. So glad that you've all joined us, and so grateful to you, Dr. Gatys. I would personally like to extend an invitation for you to come visit us at MIU sometime. Maybe in the middle of winter, but you're very welcome here. We would be so happy to have you here and give some talks.
Get in touch with us.
And the students would like to know if it's all right for us to put them in touch with you.
Yeah, totally, absolutely.
Okay.
And I try to help as much as I can, but of course, there are always limitations to what you can do, but I'll try to be helpful for sure.
Yeah, so let me know, send me a message, see me after, and I'll put you in touch with him through the email. Okay, great. Any other comments or questions here from anybody? Have a great day, Leon. Thanks again. Really wonderful to meet you, and your presentation. We really appreciate it. Thanks.
Thank you very much. It's, really happy to be here, and thank you very much for the invitation and opportunity to speak and connect with you.
Thanks again. And everybody who joined us online, thank you. A lot of little thank yous are coming in by text. Okay, that's it, everybody. See you again soon.